Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of determining slope, specifically how we can determine slope if given a graph, table of values, two pairs, or even an equation, and we'll do it in 5 minutes or less. So I've got three different representations here. I've got a graph, I've got this table of values, and then I also just pulled out two of the points on the table of values. This one right here, just because sometimes in Algebra 1 we are asked to find the slope, and we are given one of these three options. And so you see the 2 points that I've circled are right here and right here. It doesn't matter which of these you get. You're going to use the exact same strategy. You're going to use our strategy for slope, which is our change in y over change in x, rise over run. And you can get that exact same thing from all three of these. Let's use these 2 points. If given a table of values, I can use other points, but I'll use those 2 points. If given a graph, I can find some other points, but I'll use these same 2 points. Because you're just going to calculate the change in y over change in x. Now as always, let's go ahead and label these x1, y1, x2, and y2. I just don't want to get confused here. So what's my y2? Negative 5.5 minus, what's my y1? 1.5. Okay, and then what's my x2? It's going to be negative 1. And what's my y1? That is going to be minus 1. All right, so both of those are going to be negative, and it's kind of like minus 1, minus 1. It's like adding negatives right there. That's really what it's going to look like. So I get a negative 5.5 minus a 1.5, so that is going to be negative 7. And then all we need to do is simplify. So if we wanted to simplify this, right, we would say, well, 2 negatives make a positive. 7 halves is 3.5 if we wanted to make this a decimal. And that makes sense because if we go up 3, 1, 2, 3, and then up another half right there, we go over 1. So that's the rise, up 3.5, right, 3 full and 1 half, and then the run is plus 1. It's a positive slope. Now, how would we do this if we were looking for the slope if given an equation? So the three equations that we are used to are slope-intercept, point-slope, and standard form. And this right here, this y equals 3.5x minus 2, that's actually the equation for the table of values and the graph that we just looked at. Well, when we see something in slope-intercept form, notice that the word slope is in the actual name of the equation, which means it's easy to identify. So the slope is going to be the coefficient right there in front of the x. So whenever you see something in the slope-intercept form, just look for the number in front of the x, you'll find your slope. Point-slope form is also very similar because, look, you've got the word slope in the name, which means the slope is called out. Now, it's a little bit more complicated, but once again, you're going to look for this coefficient. Now, it's going to be in front of the parentheses that includes the x minus the x1, but either way, it's really easy to find. Where you have to do a little bit of work is if you ever find something in standard form, because the word slope is not in the title. So my suggestion would be at this point, turn it into the slope-intercept form. So take this right here, right, and let's make it look like that, because we know where the slope sits when it's in slope-intercept. So we need to get rid of this 3.x from the left. We need to bring it over to the right, so we're going to subtract it from both sides. So you're going to get a negative 6y equals negative 3x plus 6. Now, the slope-intercept form is close, but we have a negative 6 coefficient there. So it's being multiplied, so we need to divide by negative 6. What you end up doing is just dividing both terms over on the right side by that negative 6, right? And you would just get y equals, that'd be 0.5 or 1 half. And this is going to end up being a minus 1. And so our slope would be 0.5. And so remember, wherever you see it, your slope is always going to be your rise over run. And so whether you're using equations, table of values, graphs, just given 2 points, you're looking for that change in y over the change in x.